Welcome to Train Signal. I'm Chris Bryant, CCIE number 12933, and this is video 3, Advanced IP Routing Techniques. We're going to take our study of default routes one step further in this section to begin with. In the previous video, we took a look at how default static routes are configured. We're going to look at on-demand routing, which is not widely used anymore. But there are certain circumstances where it can really be helpful, and we're going to take a look at that. It does involve some default routing. Then with propagating default routes, we're going to take a look at two commonly used Cisco commands that are just as commonly misused. There seems to be some confusion. They are similar. We're going to take a look at when and when not to use both of those commands to propagate a default route throughout your network. IP helper addresses help us out when we've got a router involved because, as you know, routers do not forward broadcasts. It's one of the first things you learn as a CCNA. However, this being Cisco, there must be exceptions, and also that really can't affect our routing or our network processes as a whole when the routers don't forward any broadcasts at all. So we'll take a look at IP helper addressing, and then finally, IRDP and HSRP. And if you've never heard of either one of those, that's not a problem. You'll know exactly what they do when we're done with this video. Basically, I'll tell you right now, they're fault tolerance protocols. They help us cut over to a working router when the router that we were using no longer works or no longer exists. So before we take a look at those, we're going to discuss on-demand routing first. And as I mentioned a few minutes ago, you really don't see a lot of use of ODR in production networks anymore. It does have some good points, as you see here on the board. The first note I made for you is that it doesn't create much of a load on router resources because it is going to actually use our old friend CDP. Remember memorizing all those little facts about CDP to get your CCNA? Well, here's CDP again. And what on-demand routing actually does is it uses Cisco Discovery Protocol to allow routers to communicate with each other. And the drawback is that ODR is useful only in a hub and spoke network. That's it. That's the only time that you're going to ever see ODR. Now, as I mentioned, it doesn't create much of a load on router resources, because, as you know, CDP has very little overhead. And when it comes to Cisco routers, everything has a cost, everything that we do. I mean, there's a reason that we don't rush right back to the production network after taking a class or watching my videos or working in your home lab and saying, hey, I learned 37 new commands last night, I'm going to put them all on the router. Don't do that. Even if you're tempted, don't do that. Because everything we do on a router has a cost in router resources. It's going to use some memory, it's going to use some CPU, and pretty shortly all these little things you put on a router add up. OSPF is somewhat router intensive, but ODR is not. It uses CDP, and the only time you can use it is in a hub and spoke network because it does use default routing. What's going to happen with ODR is that the spokes are not going to have specific routes, specific destinations. Let's say that if our left-hand spoke needed to reach the right-hand spoke and the right-hand spoke had a network 2110 on it, the left-hand spoke wouldn't see that. It just has a default route. All the spokes are doing is sending all their data to the hub, and the hub router is going to have a complete routing table and take care of the routing from there. So again, you have to have CDP running, and you have to have a hub and spoke network to run ODR. Again, you really don't see very much of ODR anymore. I'll tell you this, if you do a Google search and you put in Cisco on-demand routing, the first 10 matches you get are all related to ISDN. That's how little ODR you see. The other thing to look out for, as you recall, CDP is Cisco proprietary. If you put a Cisco router and directly connect it to a non-Cisco router, CDP is useless. The official word from Cisco is that on-demand routing is a Cisco proprietary technology, that you can only use it if all devices involved are Cisco devices. It is not suitable for a multi-vendor environment. Now, if you do keep up with that search on Google or your favorite search engine for Cisco on-demand routing, you're going to find a PDF written by someone at Cisco that will tell you that ODR is not Cisco proprietary and that you can use a non-Cisco router as long as it's one of the spokes. The hub still has to be a Cisco device. I personally have not tested that, but I will tell you that the official word as far as the BSCI exam goes, and the official word, if you ask 9 out of 10, if you ask 10 Cisco engineers, probably all 10 of them would say ODR is Cisco proprietary. It's not suitable for a multi-vendor environment. So if you keep on searching and you find that document, that's great that you know that. But for the BSCI exam, the official word really is that this is a Cisco proprietary technology. Now, we've talked quite a bit about static routing here. We've talked about how to write a static route. We looked at how to write a default static route. Those were both in the previous video. And now you've seen that ODR actually sends only a default route to its spokes. Well, we may be in situations, though, where we create a static route and we want to advertise it. We want to propagate it throughout the network. This can get confusing and a little bit frustrating, so we're going to take quite an in-depth look here at the different ways to propagate default routes. And what we're going to do here first, this is going to be the network setup that we use for this particular example. And again, routers 1, 2, and 3 over the frame network 172.12.123.0. They're running RIP version 2. Router 1 has a directly connected network 100.110/24. It's an Ethernet segment, and router 1 wants to propagate this as a default route. And we've got a couple of options here that we're going to put on another whiteboard and see when we should use them and when we should not. Propagating default routes. We've basically got 3 options. We have the IP route command. We've been using that throughout this course. We have the IP default network command. And we have, finally, the IP default gateway command. Those are the last 2 commands there are the ones that are commonly confused. Now, like I said, I've done some of this in production networks. I've done plenty of it in labs, and it can get a little frustrating because it differs a little bit between protocols. The one we're going to look at here is RIP. And with RIP, we've got 2 options really, either IP route or IP default network. And if we use the IP route command, we can create a default route with IP route. That's the command we use. That's not a problem. But to propagate it, this requires manual redistribution of the static route. You may be familiar with route redistribution. You may not be. It sounds so innocent, but it can lead to quite a bit of a headache. But we're going to be looking at route redistribution throughout this course, because when you master the basics, it's like anything else with Cisco. When you master the basics and build on that, then you're going to be fine. It's when you try to jump into advanced route redistribution scenarios where you haven't done the basic work that gets you in trouble. That's what trips up quite a few CCIE candidates. So we could do that, but we're going to use the IP default network just to show you a couple of quirks with this command, because one key with the IP default network command is that it requires IP routing to be enabled. And you may think, well, you know, just about everything we do on a Cisco router requires IP routing to be enabled, and that's true. I mentioned that here to compare it to IP default gateway in a few minutes. Looking again at, well, let's take a look at our pod here first. And again, we've got RIP running over the frame relay network already. And now we're going to propagate a default route on router 1 in RIP. So you know what it looks like. We're going to use simply the IP default network command. And notice that I'm using the classful network number. That's because this is a classful command. Even though I'm running version 2 of RIP right now, I have to use this version of the default network command. I've seen it where you have to put in the classful and the classless command. Sometimes you have to do that. It doesn't hurt anything, but here I don't think we're going to have to do that. So we've configured that as a network, as our default network. Let's go downstream to our routers 2 and 3 and see what kind of RIP routes we're looking at. Now this is interesting. This may be the first time you've ever seen a RIP generated default route. It's to 0000, just like we saw earlier with the static default, but it is a RIP default route. There's the asterisk. There's the administrative distance of 120, which you would expect. And it has marked 123.1, which is the next hop from router 3, as the gateway of last resort. So it's really just that simple to use IP default network with RIP. Let's go back to router 1. See if we see anything unusual in that routing table. And we do. Notice that it's marked as a static route here. You see 2 asterisks. And it's marked the classful network 100.0.0.0 as the default. And it's even marked up here, gateway of last resort is. So this is how you propagate a network as the default network with RIP. And some comparisons to make to other protocols here. When we use default network with RIP, remember the network that we're going to see is the all zeros network, 0000. With OSPF and IS to IS, they will not use this command to propagate it, to propagate a default route, that is. So they don't recognize this command. Now IP, IGRP, and EIGRP do. What you should see is the full network number marked as a default route. But getting that to work with IGRP and EIGRP is not easy at all. It just that those two protocols simply don't seem to like IP default network. That's more of a real-world piece of knowledge than for the exam. The keys here for the exam is that for IP default network, we have to have IP routing enabled. With RIP, the network that we're going to see, as you saw, is actually a RIP default network to the network 0000. And OSPF and IS to IS themselves do not recognize this command. Now I mentioned that we could use the IP route command and manually redistribute the static route. So we're going to do that. This is going to be an introduction for you to route redistribution. We're going to take that last command out simply by putting no in front of it. We'll save that and go to the downstream routers. And there's that convergence problem, you know, because now it's going to take a little while for that command to disappear. Let's clear the routing table. This is where clear IP route asterisk really comes in handy. And we'll see, okay, we got rid of it. So we would have been sitting there for quite a long time. Certainly you're familiar with all the hold down timers with RIP, and that you can see that with show IP protocols. That's one major drawback to a distance vector protocol, is how long it takes a route to actually get taken out of the table. So anytime you make a change like that, even in a production network, if I did something like that on a RIP network, I would clear the routing table in that particular instance. So we've taken care of that. We now have no default network, no default route. We're going to go back to router 1 and use the IP route command to propagate, and then the redistribute command, to propagate that default route. So first we're just simply going to write the command as you'd expect. And we're going to use the exit interface this time. Ethernet 0. So there is our default static route. And if we do a show IP route here, we should see it right down there at the bottom. And note, as I mentioned in the previous video, note that when you create a default static route with a local exit interface, it's treated as a directly connected route and therefore has an AD of 0. Well, that's fine so far, but of course there's no reason for router 2 or router 3 to be seeing that. And see, here's what I was talking about earlier with the routes taking a while to leave when you're talking about distance vector protocols. Let's see, clear IP route again. I've seen it take a long time to leave the table. We're still getting them, although it should be gone. Let's clear that routing table on 1. A live lesson on why you don't use distance vector protocols on a WAN. Still getting it from serial 1. Are we still getting it propagated over here? We still are. So let's take a look here at why we're seeing that. I bet I know. We're going to take a look at router 1 and see another little trick with this command. And let's take a look at our config here. Because, you know, when you write a command in global configuration mode, like we did, you expect to see just say IP default network 100.0.0.0, but that's not what happens here. It actually puts in a static route. So sometimes getting rid of this is not the easiest thing either. So we're going to do this. No IP route, and just repeat that command. Because remember, on router 1, we didn't write that route. It was put in by the default gateway, default network command. Let's see if we can get rid of it this time. Yeah, now we're getting rid of it. The joy of distance vector protocols. But actually, that didn't have anything to do with the distance vector protocol. It's just another byproduct of using the IP default network command. It inserted this IP route, and we never wrote that command. There's no reason for us to write that. The command did it for us. So even though we took the default network command off, we still needed to go in and manually delete that. So let's just check one more time on our downstream routers. Yep, it's now gone. Okay, so now you know what to look for, because that's what people tend to leave in if they work with default network and they can't get it to do what they want. And go, I'm just going to take the default network command off. Doing that is not enough in the real world. You got to go in and get rid of that route. So now let's go back up to router 1 and run a show IP route command. And there's the static route that we expected to see. But now we want to propagate that. And if we want to propagate that, we have to perform route redistribution. And again, you're going to see a lot of this throughout the course, and then there's going to be a separate video on it later in the course. But here's the basics for it. We have to go into, first off, the routing process that we want to redistribute that route into. And here it happens to be RIP. And we're going to use the redistribute command, however, with several options right after that. And we're going to use iOS help throughout this. I mean, all of a sudden, hey, we got a lot of options here. Most of these are, actually all of them, taking a look at it, these are all protocols or route types. You see ODR in there, OSPF, RIP, static, which is what we're going to type here, connected, EIGRP. So we're going to redistribute the static routes into RIP. We're going to do that right now. Now, redistribute static, that should do it. We'll see. I'm going to show IP route RIP, and there it is. And we go over to 3. And there it is. Because we are not looking, this is shown as a RIP default route, but we didn't use IP default network to get it in there. We used the redistribute command. So that's just another way to propagate a default route. You use the IP route command, but then you've got to use the redistribute command. Key here that you may never see outside of the exam because you don't see a lot of IGRP. IGRP does not understand that kind of route to 0000. So I'm going to just make a note up here. You cannot use IP route and redistribution with IGRP. Can't do it. So if you happen to run it, I don't think you're going to run into many IGRP redistribution scenarios in your life, but if you happen to run into that one, don't get confused. You can't use it. You can't use redistribution of a default route into an IGRP process. Finally, and I think you'll agree with me, this is a lot of little rules and a lot of little touchy things for something that seems so simple. And if you do a Google search or your favorite search engine search on any of these topics, you're going to see tons of matches. You're going to read a lot of stuff out there because it can get confusing. But IP default gateway doesn't get too confusing because the one thing that has to happen for you to be able to use the IP default gateway command, IP routing must be disabled. Now granted, you don't run into that scenario too often either. And outside of your CCNP exams, you may never see it. But you could be in a situation where IP routing for some reason is disabled, but you can still set a default gateway, a gateway of last resort. But that's where you have to use the IP default gateway command. So just going over these again, these are the 3 methods by which we propagate a default route. And if we use the IP route command to create a default route, we have to manually redistribute that into any dynamic routing protocol that we want to see it. And that's what we did here. Routers 2 and 3, the other RIP routers, could see it as soon as we use the redistribute static command. IP default network, it's going to send to your RIP routers a network of 0000 as we saw. OSPF and IS2IS don't recognize the IP default network command. You could try to use it on a router running OSPF, but you're not going to get that router in there, that default route. We're going to look at other methods of default routing with OSPF in those videos. And then finally, with IP default gateway, that's the command you use if IP routing has actually been disabled. Alright, I think that's enough talk about default routes for a while. I think you've had enough of that. We're going to look at that again later in our OSPF discussion. But for right now, let's use the knowledge that we picked up in our CCNA studies to diagnose any kind of problem we might be seeing here. We've got a PC on one network segment, and it just booted up, and it's got to get its configuration information from a DHCP server. So the PC is going to send out a UDP broadcast, because DHCP is a UDP protocol. And it's going to send out a broadcast, and it needs to get its information from DHCP. Now, you're probably already nodding your head, or you probably already see the problem, and that's great. The issue here is that routers, while they accept broadcasts, and they generate broadcasts, they do not forward broadcasts. So we've got a real problem here because we didn't listen to Bill Gates, we don't have a DHCP server for every segment, and now we're in a lot of trouble. Well, actually, we're not in that much trouble, because Cisco has a very simple command that will actually take UDP broadcasts and translate them into a unicast, and unicast them to whatever IP address we decide they should go to. And this command is the IP helper address command. Very simple command to configure. It's simply the command followed by the IP address that we want these UDP broadcasts to be unicast to. Now you may think, well, that seems pretty simple. That's the end of the video. No, it's not the end. It's not that simple. You knew that. The IP helper address command is an interface level command. So just like back when you used to study access lists and you had to decide which interface to put an access list on, we've got to decide, first off, which one of these two interfaces this command should go on. And it should go on the interface that will be receiving the broadcasts. So in this scenario, if we had Ethernet 0, 100.111, and then Ethernet 1 is on the 172.12.123 segment, this command needs to be configured on Ethernet 0. That's the interface that will be receiving the commands. So now we've got that down. We've got the syntax down. It's a pretty simple command. But we need to know which UDP broadcasts are being forwarded by this command, because it's just not that simple, my friends. Not all of them are, and we don't really want all the UDP broadcasts to be forwarded by this command. That's a lot of broadcasts, as we'll see on the router in just a moment. These are the default UDP broadcasts that are forwarded by IP helper address. I think it's an excellent idea for the exam for you to know all 8 of these. I think it's a great idea. Time, TACACS, DNS, remember DNS runs on UDP and TCP, the BootP DHCP server, BootP DHCP client, TFTP, which is a very common Cisco technology. We use that all the time to copy configs from one router to another, to upgrade iOS images. We use that regularly. The NetBIOS name service and the NetBIOS datagram service. I would know the names and the ports in that list. Now, going back to the previous diagram, this is just a DHCP server. So maybe we don't want DNS broadcasts and NetBIOS broadcasts and time broadcasts and TACACS broadcasts to be forwarded to that DHCP server, and they don't have to be, because we can remove ports from this default list with the No IP Forward Protocol UDP command. That's the command to remove the port, and then right after that you just specify the port number. And if we want to add anything to this list, we simply use IP Forward Protocol UDP, and that's it. So let's take a look at this in action on the router, and you're going to see it's a pretty simple command to go with here. We're going to go over to 3, I think. No, let's stick with 2. Let's stick with 2 and get out of interface config mode. Remember, this IP helper address command goes on the interface that will be receiving the broadcasts. And it's simply IP helper address followed by the address itself. Now maybe, we look at that list, we look at this and we go, hey, this is fantastic. But now we're looking at this list and thinking, well, maybe we don't want all 8 of these broadcasts to be forwarded to that DHCP server. Maybe we just want it to be port 67 and 68. Well, in global mode, I believe we'll find this. No IP Forward Protocol UDP, then use iOS help, and you're going to see quite a list of ports here. Now, we've got these memorized, and maybe you just take off port 37, and that's fine. Now time will not be translated into a unicast. But maybe we want to add some other obscure port, one that we don't use that often, and we just can't quite remember, so what's the echo port number? What's the discard port number? What's the BIF port number? No one remembers all these port numbers unless you work with them all the time, and I don't remember all of them. I use iOS Help here because by using iOS Help you get this huge default list of ports, and these aren't all the ports that a Cisco router understands, but it's an awful lot of them. So again, get used to using iOS Help whenever you can. It really is quite helpful. So now you've seen how the IP helper address works to begin with. Let's just review a bit because it's a new concept for a lot of us. That when a router receives the UDP broadcast, by default, of course, it'll be dropped. Then we can use the IP helper address command to specify an address to unicast these broadcasts to, but by default, it's going to be all 8 of these broadcasts. And if we want to remove some from the default list, we can use the No IP Forward Protocol UDP command to do so. And if we want to add ports to it, as you saw there, use the IP Forward Protocol command, UDP. Don't forget UDP there. And if we wanted to add the talk port here for some reason, we type in the port number, and it's iOS Help that shows us all those port numbers in the first place. Very helpful feature.